Welcome to Techno Sapiens.
Hey everyone, I am absolutely thrilled you're here for this explainer. Today, we're zooming in on a critical safety device that is quite literally hiding right in plain sight in our own homes. You know, we walk past that gray metal box in the hallway or the garage all the time, probably without giving it a second thought. But inside that little box, well, it's a fascinating piece of engineering designed for one very specific purpose: to protect you, your family, and your entire home. So let's jump right in.
Okay, I want you to imagine a pretty terrifying scenario for a second. Imagine if the electricity flowing through the walls of your home right now suddenly became, say, 100 times stronger than it should be. It's a completely invisible threat, right? But the physical consequences are very, very real and incredibly dangerous. When electrical current gets that high, the wires inside your walls literally begin to violently overheat. That protective plastic insulation surrounding the wires, it just melts right away, and a catastrophic electrical fire can start in an absolute instant.
So, with that kind of terrifying power surging through your walls, what actually stops a devastating fire from starting? Well, one very specific device steps up to the plate. It's kind of like our own mechanical hero, and it takes action not in minutes, not even in seconds, but in mere milliseconds. Yep, you guessed it, that device is the circuit breaker. It is literally the ultimate line of defense, standing between our normal daily lives and an absolute disaster.
Section 1. The hidden electrical danger, the everyday threat hiding in your walls. Okay, let's really dive into this and explore exactly what happens when electricity just gets completely out of control.
Section 2. What causes an overload? The traffic jam in your wires. This right here introduces us to the very first common villain we face, the electrical overload.
So what exactly is it? Well, an overload is a dangerous condition that happens when too many appliances draw current from the exact same circuit. Just picture your kitchen, or maybe your living room. You plug in a space heater, a microwave, maybe a heavy-duty vacuum cleaner, and they're all running on the same circuit. Every single time you plug something in and flip it on, it demands more electrical current. And when you demand way too much, you create an overload. It's a simple, everyday action, but it slowly and silently builds up this intense, dangerous heat right inside your home's wiring.
And this brilliantly illustrates the problem. Think of a small, narrow road that is suddenly packed with just way too many cars. In this case, the cars represent the electrical current. When that current becomes too high for the physical size of the wire, it creates a massive bottleneck. That electrical traffic jam generates a tremendous amount of friction and, of course, heat. If you just leave it unchecked, that heat is definitely going to start a fire. But before that can happen, the circuit breaker detects this dangerously hot condition and it trips. It physically disconnects the power, basically stopping that traffic jam dead in its tracks.
Moving on to Section 3. The short circuit threat, when electricity takes a dangerous shortcut. Now we're transitioning to the second and honestly much more sudden and catastrophic villain, the short circuit.
So, as we see here, a short circuit occurs when a live wire touches the neutral wire directly. Now, to understand this, in a normal, healthy system, electricity has to do work, like lighting a bulb or turning a fan motor, before it returns to its source. That work basically acts as a safe boundary. But in a short circuit, those boundaries are completely bypassed. The live wire directly touches the neutral wire, and it skips those normal electrical loads entirely.
Our source material describes this exact moment perfectly. It says this creates a state of dangerously low resistance and huge current. Because think about it, the electricity doesn't have to push through a heavy appliance anymore, right? So the resistance drops to almost zero. And this causes a massive, explosive surge of current to flow almost instantly. I mean, without protection, that sudden, huge current would literally obliterate your wiring or spark a major fire in the absolute blink of an eye.
Okay, let's contrast these two threats directly. On one side, we have the overload. This is the sneaky one. It's a slow, gradual buildup of heat from simply running too many appliances at once. The wire just gets hotter and hotter over time. Now on the other side, we have the short circuit. This is the explosive one. It is an instant, massive surge of current caused by a live wire instantly touching a neutral wire. So we've got two very different problems, which means the circuit breaker actually needs two entirely different ways to solve them.
Section 4. How the breaker trips, the hero's weapons. Let's introduce the specific internal mechanisms the circuit breaker actually uses to think and defeat these two different electrical villains.
Now, what's really interesting about this is how the breaker actually tackles these specific threats. For an overload, that slow traffic jam of current we talked about, the breaker uses a thermal mechanism. It literally heats up right alongside your wires, and when it gets just too hot, boom, it triggers the breaker to trip. But for a severe short circuit, where you absolutely don't have time to wait for things to slowly heat up, it relies on a magnetic mechanism. That massive sudden spike in current actually creates a really strong magnetic force that violently pulls the switch open and reacts almost instantly. The contacts separate, and that dangerously huge current is interrupted.
Section 5. Extinguishing the electric arc, defeating the final boss. So moving to this final challenge, the crazy thing is, even when the breaker disconnects, the electricity still tries to fight back.
Which brings us to a frankly wild phenomenon called the electric arc. An electric arc is dangerous electricity that attempts to keep flowing right through the air even after the breaker contacts have physically separated. I mean, imagine that. The current is so incredibly strong and so determined that it literally jumps the gap through open air. It creates this bridge of pure superheated plasma. This is a massive, absolutely crucial fire hazard that has to be neutralized right then and there. Otherwise, opening the circuit actually achieves absolutely nothing.
So how exactly does the breaker defeat this final boss? Well, let's walk through this absolutely brilliant 4-step sequence, which, by the way, all happens in a mere fraction of a second. Step 1, the breaker detects the fault and the internal contacts violently separate. Step 2, the electricity fights back and a fiery arc forms right in the air between those separated contacts. Step 3, okay, this is where the real magic happens. The breaker uses an arc extinguishing system called an arc chute. This ingenious device literally forces the arc into a series of metal plates that split the arc into smaller pieces and rapidly cool it down. And finally, step 4, the arc is fully starved and extinguished. Only then is the circuit safely and truly interrupted.
So the crucial point to take away from all this is really 4 main things. An overload means there is just way too much current acting like a massive traffic jam. A short circuit means a dangerously low resistance is causing a huge sudden surge. The trip mechanism, whether it's using thermal heat or magnetic force, is what physically disconnects the circuit. And finally, the arc extinction system safely suffocates that lingering fiery electrical arc. So as you can see, a circuit breaker is absolutely not just a simple switch. It is a highly engineered, life-saving shield designed specifically to perfectly protect people, wires, and our equipment from disaster.
Which leaves us with this one final fascinating question. The next time you go to plug in a space heater, or a blender, or just turn on your television, will you remember the tiny, brilliant shield protecting your home? It's just sitting there, quietly in the dark, absolutely ready to deploy thermal sensors, magnetic tripwires, and arc cooling metal chutes in a matter of milliseconds, all just to keep you safe. Thank you so much for joining me for this explainer. Keep learning, keep asking those questions, and I will see you next time.